Okay, welcome back to our last question that we tried solving. I think we got to the point where we derived our equations. Please, if you were not following this, it means you would have to go and watch the video I posted earlier on before this one so that you can follow nicely and understand what we have here. Good. So we have our first question from here and then our second question. Now, since the object is moving and it is moving downward, remember it will have or will have a resultant force. The resultant force, F, we are using mass times acceleration. So that resultant force is due to the movement or the acceleration of the object. It's going to be equal to the movement or the force due to the weight, which is inclined at an angle theta, minus the friction, since the friction is opposing the motion. Now, the question did not give us friction, it gave us the coefficient of friction, and therefore we have to rewrite the friction equation in terms of the coefficient of friction. Now, the coefficient of friction, or the friction F, is equal to mu R. That is the coefficient of friction multiplying the normal reaction. So if we come to replace that, we are going to get the friction to be mu m j cos of theta. So that is how come we have this equation, so that in the end, if we take the masses out, then we have A to be equal to j sine theta minus mu j cos of what? Theta. So this is what we have with the equation moving forward. Then also, from the what has been given, we can say that sine theta, that is sine of 30 degrees, is equal to opposite, which is the side or the height, 4 meters, all over the hypotenuse, which is the distance covered. So we can write it here, sine theta is equal to 4 over s, where s is representing the distance. Therefore, s becomes equal to 4 over sine 30. Then s will be giving us 8 meters. The question is asking us to calculate the time the body takes to reach the bottom of the plane. The only equation that can help us here, if we want to come and use V is equal to ut plus half at squared. Remember that we have s is equal to s is equal to ut plus half at squared. The body was let go, or let fall, so it means that u is equal to 0. So the equation becomes s equal to half at squared. So this is the relation that we are going to be using to solve the question to calculate for the time t. We have already gotten our distance s to be 8 meters. So we need to come and find our acceleration. From the equation, we have our acceleration A to be equal to j sine theta minus mu j cos of what? Theta. So A becomes 10 sine 30 degrees minus, from the question, we're given the coefficient of friction to be 0.3. So minus 0.3 times 10 times cos of 30 degrees. Let's put all this in a bracket so that we know that it's in a bracket, and all of this also in a bracket. So here, A is going to give us 5 minus, if you multiply 0.3 by 10 by cos of 30 degrees, you should be arriving at 2.598. So you get 2.598. Therefore, acceleration A will be equal to 2.4019 meters per second squared. This is what we are getting for our acceleration. Good. So it implies that 8 is equal to, so we are coming back to this equation for the time. So 8 is equal to half multiplying 2.4019 multiplying t squared here in bracket. So you have 16 over 2.4019, it's equal to t squared. When you do the math, you get t is equal to square root of 16 all over 2.4019. So finally, you arrive at t is equal to 2.58. You get t is equal to 2.581 seconds or 2.6 seconds. So this is what you will be getting for your t. Please, you can go through the steps once more. Once you draw the diagram, the first important thing you do is the diagram. If you could see from how I'll solve the question, I drew my diagram first, I was able to write all the equations that has to be written from the diagram. From the diagram, you could see that you could get 3 equations from the diagram. Upward forces becoming equal to the downward forces. That is how come the normal reaction was equal to mj cos theta. So the normal is upward and mj cos theta is downward. And the mj sin theta, which is the movement of the object due to gravity downwards, is equal to the friction that is opposing it. So we have this equation here. Then previously, we could also use R and F to derive an equation for the coefficient of friction. But this question has given us coefficient of friction already, so there is no need. The only thing that we need is to find the acceleration. And the question is telling us that a body is released from rest at the top of a plane inclined at 30 degrees. What it means is that the body is moving. And if the body is moving, the body will have its own acceleration. And therefore, that acceleration A is what is coming out of the resultant force. So the resultant force is just a force that is combining the force of the body due to its weight and also the frictional force that is opposing the movement. So the resultant force is what we have as F here, which is ma, mass times acceleration, and then minus the force is equal to, the resultant force is equal to this mj sin theta minus the friction, so that we know that finally this is the result of these two forces. Okay, that is how come we have the resultant force here. Then ma is equal to, you realize that I said previously the question did not give us friction, it gave us the coefficient of friction. So you come back, you know that the friction is equal to mu r, where r is the normal reaction. So we can come and fix this equation back into this equation, but the r here is equal to mj cos of theta. That is how come we had F to be equal to mu mj cos of theta, so that this acceleration equation comes back to this. Then we can also find the distance from the information that was given. And knowing the distance and knowing the acceleration, we could write Newton's equations of motion. That is the second equation of motion. And out of it, we can come back and derive or find the time t that the object used. Kindly subscribe to my videos. In my next video, I'm going to make a little video on magnetism, but before that, we'll also have to deal with connected bodies, where you have two masses on an inclined plane, or two masses on or hung over a light inextensible string passing over a pulley. Thank you.